Australia, the world's 6th biggest country, with the majority of its landmass dedicated to farming. A $100 billion industry and a powerhouse of global food production. Behind Brazil, it's the planet's top exporter of beef, and after Russia, the top exporter of wheat. But in the wake of climate change, global supply issues, and with sustainability goals in mind, unique innovations are being developed to help. In downtown Sydney, startup Platypus Vision is developing a grain analysing device that aims to make the process of grading grain more accurate and transparent than traditional manual methods.
Welcome to Platypus Vision. Because you've got human inspection, which is not traceable, it's simply an opinion that somebody writes on a piece of paper. Now you've got a machine which is recording all of this, providing the data which is reviewable.
The way it works is, 2 high-speed cameras individually photograph every single grain as it passes on the conveyor belt, operating at around 9,000 frames per second. Then, using computer vision, its artificial intelligence can identify what it's being fed and gauge the quality of the crop.
If there's some insect damage, this would be quite difficult for a human to locate reliably. The machine finds this very repeatably.
And because of artificial intelligence, it's getting smarter all the time, which in this instance is rather handy.
The one thing about grain is it's a natural product. There's always something that you never saw before. A new variety will come out, and some different disease will come out, and the machine really needs to be able to learn this on the fly.
But I've got a burning question I have to get off my chest. Hold on, farmers have been growing wheat successfully for centuries. Why do we need a machine to take over that job?
It's been an issue for 5,000 years since the Egyptians were doing this, and humans provide a subjective opinion, and what's actually required is an objective assessment.
But this isn't just for growers. In farming, supply needs to meet an increasingly demanding customer.
Consumers are becoming more concerned about the traceability, where product came from, how it was processed, how it was produced. But being a natural product, people worry about biosecurity risk. Are we exporting bugs? Are we exporting weeds and seeds that might be dangerous in any given environment? It's important to be certain that that's not happening.
A few hours west of Sydney, I've come to see another device, this time taking the guesswork out of producing my favourite Australian export, wine. BioScout sniffs the air to prevent diseases. Fans draw in air particles through this little nozzle here and spread them over effectively a piece of sticky tape. A camera is then used to analyse the spores on the tape, which is able to then infer to farmers and growers how healthy their crop is, how effective pesticides are, and crucially, if they should be even spraying at all. How big is this vineyard then?
So the whole vineyard's about 60 hectares. The whole property itself is about 150, so a very large property.
Winemaker Charles Simons uses it on his vineyard and was so impressed he decided to join the company full time.
I put my money where my mouth is. We farm this property purely based on that data. The farmer here, or me in this instance, can see real-time information on what risk of disease is floating around us in the air. So I can base my decisions on spores and weather and historical long-term average data and make a more better decision, not just for me, but also for the environment. Because at the moment what we're doing is we blanket spray agrochemicals. But what are you spraying for, right? If you don't see the disease on your plants, how do you know you've got disease? It's like you taking Panadol for a headache, but you don't have a headache. So why are you taking Panadol?
The unit talks to a virtual dashboard, giving growers confidence to use fewer chemicals. So what sort of things can you see? What sort of things is it picking up on?
So in this instance here for viticulture, we're picking up botrytis, bunch rot, eutypa, downy, and powdery mildew. The more data we feed it, the better that forecast model will become. Now what AI is doing is it's looking at the local weather conditions, and it therefore takes the spore load plus the weather conditions to tell you your risk of infection. It helps you with a bit of the guesswork now. So if you were, for instance, planning on spraying today, there is no need to spray today.
Tools like these may seem luxurious, but growers face regular export challenges.
They've been mandated from the top down to say you need to stop spraying certain chemicals because you cannot export your wine to this country if there is residue of agrochemicals.
Back to the outskirts of Sydney, researchers are developing future farming methods within greenhouses.
We're looking for high quality produce, high volumes of food produced near cities in major areas. So these high-tech glasshouses are a way to generate that, but they are energy intensive.
They're investigating ways to maximise crop growth, and one of their smart solutions is all around us.
Sunlight contains all the colours of the rainbow, and plants are green because they reflect green light into our eyes. They're not very good at photosynthesising green light. They're better at photosynthesising red light and blue light. So what we've been able to do is use fluorescent and luminescent molecules which go into a film which makes a smart material.
And plants love red. They love red wavelengths. So the idea is that by having more red, we can get more growth. It can also enhance nutritional characteristics, fruit quality characteristics. So it has a lot of potential to boost plant growth and boost food production.
But they're taking the film a step further, combining it with solar cells to make greenhouses more sustainable. See, normally solar panels would be facing the sun, but in this instance, the sun's hitting this panel here, which has got the film on it, which is then sending the high value light onto the crops so they can grow better, and it is reflecting the light that it doesn't want onto the solar panel, which then is absorbing that and converting that into electricity. Green power that will help regulate fluctuating temperatures.
As the world is threatened by climate change, the elements of nature outdoors will be exposed to that, and you can't mitigate that. But in here, we can mitigate those effects of climate change because we control it.
Discovering all these innovations on this trip has been inspiring, but has also illuminated the complexity of today's Australian agricultural industry, issues affecting our global supply chain and our planet.